friends, welcome back to my class. In the series of learning programming in C, in the previous video, we have discussed about the introduction to recursion. We have seen what is recursion and some sample programs on recursion with the dry run and actual execution. In today's video, we will discuss about the types of recursion. The most frequently used types, that is direct and indirect. You have still few more types like tail recursion, non-tail recursion, linear recursion. So like this, there are still many more recursions when we get into the data structure concept also. So we will get to know about all these types of recursions one by one in separate videos. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. And if you like the video, please click on the like button and share the video to all your friends. Your support and encouragement will be a motivation for us so that we can come up with more videos. And please watch the video till the end, because any concept will not be clear if you watch the video incompletely. So if you want to understand the concept clearly, please watch the video till the end. Do not skip the video. And please be watching the videos continuously so that you can get the link of every content, or else you will not understand the concept. So please be watching all the videos, check the playlist, you will get the list of all the videos, and watch the videos. You can make notes of that and you can have a track of every content. So let us start with this content, that is types of recursion, in today's video. Types of recursion. The most commonly known type is direct and indirect recursion. The recursion example programs that what we have dealt in the previous video is the example for direct recursion. Well, in today's video, we will see one more example to understand this direct recursion still in a better way. And we'll talk about the indirect recursion in the next coming video. So we have to understand direct recursion first clearly. So let's get into the example of direct recursion, because we cannot simply explain what actually this direct recursion is. We have to understand this with small examples. So let's see that. So we have seen normal function. So for example, we will have the main function. Inside the main function, we will have a function call. Say for example, I'll say it's void main. I'll just make a function call, say add. Okay, so somewhere else we will have the code of that. Some code will be defined for this. This is calling function and this is called function. Well, we have discussed about all these basic things in the previous video itself. Please do check the playlist. This is calling function and this is called function. Okay. So we have the main function, and one more thing that what you should remember is the execution always starts from the main function and it ends in the main function itself. So here when we come to the main function, some statements gets executed and then we have the function call. So when a function call is invoked by the compiler or when it encounters a function call, the control will be to the declaration, some declaration will be done for that, and the control will be to definition, and the definition part gets executed. So from calling function, the control will be to called function. After executing this complete code of called function, the control will be back to the place where the function was called and the remaining statement gets executed and the function, main function ends. This is the normal scenario that what you people have already learned. Now what about the recursion? Say we have the main function here and inside the main function, some function I am going to call. So let me take the example of add itself. Then the add function will be defined. Inside the code of this add function, what I'll do, I'll call the same function again. Okay, so look at here. So execution starts from the main function. I have a function call here. Control will be to the definition. After checking with declaration, it will come to definition part. So calling to called function. When I get into the called function, I have a function call here also, where that function call is a call to the same function itself. So the control will be to the same function. Then once again I'll get inside, right? When I get inside this, again a function call, it goes on, then again it comes, again goes on, it goes on like this. But where is the termination point? So for that we will have two cases. We have dealt with that. So we have base case and recursive case. So base case will tell you where this recursion process should end. So based on that, the recursion will end and then control will be back to the place where the function was called. So here when I start from the main function call, I'll come to this function definition. I will have some statements. Again a function call to the same function. This is recursive process. What is recursion? A function calling by itself. So I am calling the add function, the same add function in the same add function code itself. So the control will be back to this place. When the control will be back to this place, again the statements gets executed. So when the base case condition gets satisfied, so we must be very careful to have the base case. The base case statements must be put clearly. So we must be very careful while having the base case condition. So when the base case condition gets satisfied, some return statement with value or without return, it will carry to the place where this function was called. Where this function was called? In the main. The control will be back to this place. So this is how the recursion process goes on. So let us see this with a small example program like this. This is what direct recursion. The function calling the same function directly. This is direct recursion. Directly it is calling the same function again. So when the function gets invoked here, the control will be back to this place. Again back. But where to end this process? So you will have a base case. Based on the base case, the recursive call gets terminated and the control will be back to the place where the original function was called. So let us see this with a small example. So here we have the example to discuss with direct recursion. A function calling by itself directly is called as direct recursion. So how the process takes place, let us see that with this example. And this program is finding the sum of natural numbers. Say sum of natural number 5 is, it is 5 plus 4 plus 3 plus 2 plus 1, which is 15. That is what sum of natural numbers. This answer we need to get in this complete process. So let us see how we are going to get this answer. So as usual, we have the declaration, we have the call, and we have the definition, we have base case and recursive case. So here in the declaration, the name of the function is sum, return type is integer, and only one argument which is of integer type we have taken, that is declaration. In the main function, execution always starts from the main function. That you should always remember. It always starts from the main function and ends in the main function. Now, in the main function, we will have a local variable a to store the result of the sum of natural numbers. And here we have the function call. When we have function call, I am passing one actual argument. This is what the actual argument. And this actual argument is taking the actual value itself. I am not taking the value from the console. I am just straight away passing the constant value, say 5. If you want to take some other value, you can just scan through the console and pass that argument through variables. But here I have straight away taken as a constant value. As soon as the function call is encountered by the compiler, the control will be to declaration to check whether the same function is declared, the same argument and same return. Everything gets matched. Then the control will be to the definition. In the definition part, we have totally how many statements? We have totally 4 statements. 1, 2, 3 and then 4. This is what the base case and this is what the recursive case. So how this flow takes place? Let us see now. Now function call gets encountered. I am passing the value actual argument 5. Then declaration, it gets checked. Control will be to definition. And I have a local variable as formal argument. This is what the formal argument. X is formal argument. So here this formal argument X is receiving the value 5. Now let me write the memory for this. So when a function gets executed, you will get 2 frames of memory. One frame for the main function, the other frame for the sub-function. So that is what the stack memory. So in the stack memory, all these statements gets dumped. We have another memory called as heap memory that we are going to deal when we discuss about pointers. That we will deal in separate video. So here in the stack memory, I will get the memory to store these 4 statements. So when I say sum of int x means x is receiving the value 5. Right. So let me write it as sum of 5. The function called sum of 5 is invoked. So here the first statement it is going to check is x equal to 1. X means 5. Is 5 the first statement. 5 equal to 1. Statement 2, return x. Is that gets executed? No. 5 equal to 1? No. So return x will not be executed. I'll come to statement 3. Else part gets executed. So else gets executed. Statement 4, I say return x plus sum of x minus 1. See, when we have a recursive case, the recursion code that what we will have is the simplest form of the function that what we are writing. So we say x minus 1. So it is x plus return, I say it is return x plus, what is x actually? Let me write the values. X is 5. 5 plus sum of x minus 1. 5 minus 1, it is 4. So it is the function called to the same function. So I am calling the same function once again with a new value x minus 1, that is 4. So x is receiving how much? It is receiving 4. Okay. So it is a function called to the same, direct recursion. A function calling by itself directly. So again the control will be to the same function but with the simplest form. So here once again I say sum of 4. So when I say sum of 4 function call, again the 4 statements. First statement is 4 equal to 1? No. So condition not satisfied, return x will not be executed. So I will come to else part. When I come to else part, the 4th statement gets executed. I say return x plus, that is 4 plus, again the simplest form of the function, that is 4 minus 1, which is 3. Again the function call. So now with the value 3, now x is receiving 3. So it is the function call for sum of 3. Again all the 4 statements is 3 equal to 1? No. Statement 2 will not be executed. Statement 3, that is else part. 4, I'll say return x. X is how much? 3. 3 plus sum of 3 minus 1, it is 2. Again a function call with a new value, that is 2. Now I am receiving 2. So it is 2. So I say sum of 2. So again check the condition, all the 4 statements once again. 2 equal to 1? No. Condition not satisfied. Else part. Then 4th statement. I say return. It is 2 plus sum of 2 minus 1, which is 1. Again the function call, same function 1 with a new value which is 1. So I say sum of 1. Again 4 statements is 1 equal to 1. Look at here. All the 4 statements will not be executed. All the 4 statements means all the statements will not be executed. Every time the recursive case will not be executed. There must be some termination point and that is dealt with base case. Now the base case is getting executed. Is 1 equal to 1? Yes. Condition satisfied. I say return that x value. What is x? It is 1. Right. I say 1 means x is receiving 1. 1 equal to 1. Return x. Return that 1. Where? To the, see, the remaining 3rd, 4th statement will not be executed here. I say return 1. Return, see, sometimes, in some cases, there may be some scenario where we simply say return. Simply say return in the sense to the place where the function was called. See, there is no certain rules like we have to return with value itself. There may be a return without value also. Return just says you get back to the previous function call. This is what the forward process we have dealt. See, this process you should know clearly. In the recursion, especially this forward process and then the reverse process, backward process. In the forward process, we go on dealing with the recursive cases. See, I say return 5 plus sum of 4. Nothing is written, no computation done. Simply function called the same function gets invoked once again. Then again see here, nothing is computed. Again call, again call. How many times I need to call? I should have a termination point. There will be some termination point where I need to have such kind of condition so that the recursion gets terminated. This is what the case here. And while returning, I may return with value or without value. Return in the sense, get back to the backward call. So I say return, here I am returning with value. It may be without value in some cases. Okay, that we will see in some data structured programs when we will deal with data structured programs. Here I say return 1 means I am returning 1 to the place where this sum of 1 was called. Let me write it in different color, you can make out. Sum of 1. Where the sum of 1 was called? It was called here. So to this, see here, I initially went through the forward process through recursive call, and now I am getting back. This is backward process, forward and backward. We did with all the forward process. Now we are dealing with the backward process. I say return 1 means where to return? To the place where this function call was done. Where was the sum of 1 was called? In the previous one. So sum of 1, I'll get the value 1. So what is 2 plus 1? It is 3. So return 3 means where? To the place where this sum of 2 was called. So here sum of 2, I'll get the value 3. Again return 3 plus 3 means how much? 6. To the place where this sum of 3 was called. So here sum of 3 was called. Backward, I am going backward. So it is 1 plus 2, 3. Return 3 plus 3, 6. Return 6 plus 4, 10. Return to the place where this function was called. Where sum of 4 was called. Sum of 4 was called here. For sum of 4, what should I return? It is 10. Again 10 plus 5, how much? 15. Return this 15 to the place where sum of 5 was called. Where this sum of 5 was called, in this main function here. So to this place, what will be my answer? It is 15. So A gets the value 15. So my final answer is sum equal to percentage D, print the value of A, it is 15. So hope you have understood this forward process and backward process. You have to write down this, then only you can understand in a clear way. So this is what the dry run we have seen. So let us see the actual execution of the program.
So here is the program for finding the sum of natural numbers using recursion. This is what the function declaration, and here is the function call sum of 5. The control will be to the definition part here. This is what the complete definition part, and this is the base case. This is the base case, and here we have the recursive case. So well, we have seen the dry run of the program. Let us see the actual execution now. Yes, the sum is equal to 15. So how we got sum equal to 15? We saw that in the dry run. So hope you have understood with the recursion program, and this is what direct recursion. That's all for today's video. See you in the next video. Till then, take care. Bye-bye.